Hello, everyone. Welcome to the sixth session of the IoT course. I hope all of you are doing well and ready for today's class. Okay, so we have covered so far already. I'm surprised to see that. So now we are at our sixth session. Is that going to be dealing with networking and the internet? So far we have covered like on this side, like things, adding sensors and actuators to those things so they can be more interactive with the real world. And then we talked about microcontrollers and how we can add computational capabilities to those things to make them smarter, right? Today's focus is going to be on this side, which is the internet connectivity, right? So why do we want to connect things to the internet in the first place? Okay, so what benefits can we get from having our things to be networked? Okay, so we can enhance the features. So for example, consider a car having a network connection and they where it can communicate with other cars so they can tell each other about the traffic situation, for example. So if there's a traffic jam somewhere, then other cars, they can like make an alert to each other that don't go there, this place is congested. And we're seeing this in Google Maps, right? So when you say like, oh, there's more traffic, we just like they ask you to put like to give your feedback on how's the traffic today, and this is shared with everybody, right? And so if the cars has the network capability, then they can do this autonomously without having us to like enter that, right? Also, through networking, we can access more databases and computational platforms. So we said to have a thing being moved into an Internet of Things, we're going to give it some sort of computational capability. And Bismillah, me going back to the Arabic. طيب. فلما تكون الديفايس فيها network connectivity، الكومبيتيشن كابيتال اللي احنا ندخلها مع الديفايس ما تكون كبيره، صح؟ يعني احنا بنتكلم على انه المايكرو كنترولر في مثلا small RAM، يعني ما يعني حيكون enough just to process a small sensor data, right؟ بس نحن لما تكون عندنا access لما نجمع كل الداتا حقت السنسورز، assume that we're مثلا dealing with an agriculture application. طيب نجمع الداتا من كل السنسورز، بعدين نرسلها لهذه الديفايس عندها قدره انها ترسل الداتا اللي عندها لسنترال سيرفر. هنقدر نعمل bigger computation on large amount of data ونطلع ب more insights and useful feedbacks. Okay, ف having a network في الانترنت of things devices it's not an option. هو مفيدة بس it's not an option. It's not like you can do it or you can't do it. لا، إذا ما في network connectivity في الديفايس then it's just an embedded system. It's not an IoT device. Okay. طيب هنا في IoT عندنا 2 layers of connection or 3, but let's just focus on 2 today. من الديفايس نفسها هنا those things, those are where the devices are. يعني tier 1 here بنتكلم عن IoT devices with their sensor, with their actuators. We deal with them as one unit, okay, which is the IoT device. They connect with a gateway, okay. يعني ال IoT devices do not directly communicate with the internet. Why don't we do this? The internet have a heavy protocol stack that requires lots of power و lots of memory space عشان ال IoT device تقدر تتكلم مع الانترنت directly. This is very هو فيه there are lots of IoT devices that are plugged مثلا to the wall that communicate directly with the internet without a gateway. بس ال 99% or like 90% of the IoT devices they deal with a gateway مع lightweight protocol, okay, that's usually short range, very low power consumption, okay. Then this gateway is connected to the internet. This gateway has lots of power, lots of resources, more than the small, poor little devices of the IoT, okay. So here, when we talk about the IoT, we talk about 2 different distinct type of like communication protocols, basically. Okay, ones that deal from the IoT devices to the gateway, and then from the gateway to the cloud, which is usually this is just the internet. Okay, so today's lecture we're going to focus on two types of devices: the internet, and this is from the gateway to the cloud, and from the IoT device to the gateway. And here we have a realm of, and then lots of protocols that we can choose from. It depends على الابلكيشن على الرينج. يعني if for example we're dealing with an agricultural application, then السنسرز are going to be scattered على range مدى كبير. اوكي فنحتاج بروتوكول يكون supports like a wide range. وusually الداتا من الagriculture it's very يعني small, not heavy. فمحتاجين بس هنا like paramount importance for us in such protocol إنه يكون supports a wide range. Okay. On the other hand, is أنا مثلا I'm dealing with a medical application, then the data might be heavy, and I'm dealing with heart rate, blood pressure, ممكن diabetes, EEG. Okay, this is in this case I'm gonna have a high data rate, but maybe and if people are at home, then the gateway is close by, then I need a protocol will support high data rate. All of those are protocols that you can choose from. They have their pros and cons. الحاجة اللي بتحدد which protocol to use is you are the one who are going to choose. بتحدد ده على الابلكيشن and the resources that you have. Okay. طيب let me just take a pause to make sure that everyone's following, everything is okay. Okay, never mind the background noise, guys. Okay. I'm not pausing to see if we have any questions, but please admins, if there are, let me know عشان I go back to the comment side. Okay, so the typical network architecture is like we have usually personal area networks where we can cover it pretty much by Bluetooth, less than 10 meters, everyone's happy. Then we go up a wider area, local area networks. We can do that with Wi-Fi. I think this is what we have in our homes. Okay, then we have metropolitan area networks and like less than 50 kilometers, like we're talking within a city range or so. And then a wide area network, which is like this is like basically the internet. We're dealing with multi-cities, etc. Can we adopt such an architecture on IoT devices? No. Okay, so when we have IoT devices, everything is customized. Okay, so those, even the Bluetooth here, okay, they have power requirements and protocol stack requirements that are just too much for the IoT device to handle. Okay, so why should we adopt to these? Or if I don't need all of the features that are given by Bluetooth, this was the main like motivation that like a lot of low power, low data rate communication protocols that have been developed just for the IoT. Okay, so usually when we did like not just for IoT or low power wide area networks, etc., we have a paradigm that between three distinct categories. Okay, range, data rate, and power. Okay, so you can't have the three together. Okay. Yeah, so the word is not perfect, right? So we can't have a protocol that's يعني يعطينا high data rate في نفس الوقت يستهلك very low power. Okay, and at the same time covers a high data range. Just 1 second, guys, let me try to deal with this noise. Is my screen share on, or I need to do it again? Okay, where is it? Okay. So as I was saying, that we can't have all three big paradigms of networking or communication in general be achieved. Okay. In IoT, we have to decide what's most important one for us. Okay. For example, we want to achieve high range, high, like our sensors are scattered all over the place. So then we have to deal with a low data rate kind of communication happening. Because usually power is all IoT devices usually agree that they need low power. Okay, so we either do a short range with a high data rate or a high range with low data rate. Okay, and we are going to focus on this low power wide area networks. Okay, for IoT. So there are different standards. Bluetooth, the standard Bluetooth that we have on our phones is not good. Okay, it consumes high power, but they have developed a low power Bluetooth low energy, which is consumes much less power and could be suitable for IoT devices. But we're not gonna talk about Bluetooth. We're focused on low power wide area networks. Um, uh, Protocols, and they can pretty much support all of the standard IoT applications. But again, it's up to you. You have to go see what application your application is needs, and see the different features supported by each protocol, and then you go for the one that works for you. Okay. So this is what I was saying with the paradigm of power versus bandwidth versus range. Okay. Here they're not considering the range, but so low power, low bandwidth. LoRa is not really low bandwidth. LoRa can go up to 10 kilometers. Okay, but the probably the performance at 10 kilometers is not great, especially إذا كنت في يعني جوا المدينة. اوكي. لورا is very good. هنتكلم عن لورا، هتعرفوا ايش لورا، بس is very good إذا كنا مثلا في مكان urban، يعني not urban outside، يعني مثلا rural areas. بس في metropolitan areas جوا السيتي لما يكون في different لورا يعني gateways موجودة، البرفورمانس دروبس drastically. اوكي، فلورا يعني هو مناسب للحتات الرولر لما يكون ما في lots of interference happening. اوكي. Again, I think this replicates that slide that يعني the different protocols and their suitability for different type of range or applications. هنا يعني up till here we are talking about low power wide area networks. Okay. Low power wide area يعني هم they support low power and at the same time they support wide range, and then naturally we know that they are low data rate. Okay, because we can't have the three. So if one of the protocols supports two, then the third one is not supported. Okay, so this is just by by nature, I guess. Okay, so low power wide area networks applications or protocols, they can be categorized into two categories. One of them is اللي هي unlicensed. They operate at the ISM band. ISM band stands for Internet Scientific and Medical. دي جزء من الفريكونسي. اوكي، الفريكونسي رينج. اوكي، سبكترم. خلوه مفتوح عشان الناس مثلا يستعملوه للريسيرش، something that's unlicensed for medical applications. اوكي. ف you don't need a license to operate at that. يعني مثلا ممكن تجيب ديفايس حقتك، يعني انا I can get LoRa gateway اشغلها في الرينج ده من غير ما احتاج انه اخذ لايسنس من النتورك اوبريتور at the country that I'm at. اوكي. في other type of standards that are developed by ال 3GPP اللي هي Third Generation Partnership Group project. هم دول they develop ال GSM standard، ال LTE، يعني الموبايل communication standard that we use. هم قالوا اوكي، يعني شافوا انه ال IoT industry is developing rapidly, so they want to join that field. they developed specific low power applications لل IoT بس عشان ينافسوا في المجال، يعني ينافسوا الناس السيك فوكس واللورا Zigbee and those people. Okay, هنشوف if they are يعني up to the challenge. Again, this is just a segregation between licensed and unlicensed. We don't need to worry much about them. And most of the famous ones are unlicensed, except for narrowband IoT. It's seeing rapid deployment lately. Okay, we don't need to worry about the history. Okay, أنا حاسة إنه الوقت هيسرقنا. بس إنجينو كان it was يعني developed late يعني early on 2008. كانت was famous or unique about Ingeno إنه they used the random phase multiple access technology. هتلاحظوا إنه مع في كل ال protocols that are developed for IoT in the unlicensed band أو حتى in the licensed إنه they use communication protocols that are resilient to interference and error. Okay. How can they do this? Usually البروتوكولز اللي هي resilient للerrors and interference بتكون فيها redundancy. Okay. They use lots of redundant bits عشان مثلا لو one of them is reflected, the other one reached correctly. فعشان كده عندهم low data rate. Okay. So they have low data rate because most of the bits are used for redundantly, you know. فبس the good thing إنه يعني they have high accuracy rate. But they have low data rate, which is okay. And those protocols they have like a wide range of bit rate. So Ingenu can support as high as 624 kilobits per second in the uplink and 156 kilobits per second in the downlink. Uplink means from the IoT device to the gateway. Downlink from the gateway to the IoT device. By the way, some of the devices they only support one-way communication. You know, the fact that it supports, and this is considered high within the realm of IoT, and it actually covers a good range from 5 to 6 kilometers, but it's not widely adopted. Waitlist, they have three sets of protocols, W, P, and N. They operate in the TV white spaces. Okay, and white spaces is like it's within the spectrum of the TV, but the empty gaps, you know, between within the TV space. We don't need to worry about like their details, so that you just know that there is waitlist N, B, and W. Okay. Sigfox type. Sigfox is actually the biggest competitor of LoRaWAN. You know, we said today we're going to focus on LoRaWAN. And it's most widely adopted, especially in Europe. It's very popular. Okay, it's operated in the ultra narrow band, like the 869 megahertz in Europe and 915 megahertz in North America. And the signal is extremely narrow band, so we can guess that the data rate for Sigfox is also very low. Okay, like the channel bandwidth is just 100 hertz, and we're talking about other channel bandwidth in the range of megahertz, and this is just 100 hertz. Guess how much is the data rate for Sigfox? It's as low as 100 bits per second. Can you imagine? And it's very low. Okay. And the packet payload is just 12 bytes. But some applications might just need to wake up, send a number, and go back, you know. It might be very appropriate for some sort of application that the data rate is not an issue for them. Okay. بس المشكلة في Sigfox إنه it have very tight deployment constraints. Sigfox it has to be deployed in such a way that it owns the network that it's operating in. Okay, يعني it's deployment حقته is very tight, not like the LoRaWAN. The LoRaWAN is very flexible when it comes to deployment, and it can be it can operate in a network that has multiple standards that are working around it, not like the Sigfox. But this was one of the main issues that made LoRaWAN مفضل أكتر من Sigfox. Okay, والLoRaWAN كمان الداتا ريت حقه is better than Sigfox. Okay. Also LoRaWAN is based on random frequency and time division multiple access. This is also a resilient communication standard. طيب, all of the ones I mentioned before, Sigfox, Weightless, and the Ingeno are they they support or they work on the ISM band, and that they are unlicensed basically. طيب, خلينا نشوف ال IoT protocols that were developed by the 3GPP اللي هم تابعين للموبايل نتورك. طيب, ايش الفائدة عشان انا I operate at those protocols؟ يعني اذا انا عندي الاوبشن انه I operate at a license for free من غير ما اخذ اذن or I need to pay money or something. الفائدة من 3GPP انه you have the structure already. Now الgateways حقتك حتكون البيز stations. Okay, so you don't need to worry about where do I place my gateways or you know. So يعني the structure is already there for you. So you just have to put your end devices, scatter them around, and that's it. Okay, this is that's the main benefit of using the 3GPP IoT protocols. They have 3 EMTC, not very popular. This is the most popular one of them, NB IoT or Node B IoT. It has can operate up to 50 kilobits per second in both directions, uplink and downlink. It's pretty good. Okay, and it also lower cost compared to the other alternatives. And this one extended coverage GSM for IoT. It has data rate between 70 and 240 kilobits per second. Okay, this is great, but still LoRaWAN is more favorable. It operates at a license path, no need for licensing, and it's much cheaper. Okay, than the other the devices. I'm talking about the devices. I'm not talking about the licensing. The licensing is another issue. Okay, so you have to pay money for those companies to use their base stations. Okay, and it operates at a license, and also it's supported by many industry. When they fabricate their devices, the compliant with the LoRaWAN and the support of LoRaWAN performance would be we'll find it more from the industry rather than the support of Node B or 3GPP IoT standards in general. Okay, so that's why LoRaWAN is the most favorable communication protocol in the realm of low power wide area network communication. We're going to talk a bit about LoRaWAN and where it performs well, like some use cases where LoRaWAN is used, see how their performance is done. Okay, so the topology for LoRaWAN is as follows. Okay, so we have devices, we have a gateways. Those are like LoRa gateways, and we have a server. Like this is the back end, and then the server will controls different sort of applications. Okay, so for example the end devices هترسل sensory signals حقتها. Okay, via LoRaWAN. So LoRaWAN works here. هنا الاوبريشن حق LoRaWAN happens between end devices والgateways. في عندنا LoRaWAN connection between الgateway والend server? No. Okay. What do we use between the gateway and network server? Let me go back to the comments عشان بس أشوف إذا الناس متابعين. I'm gonna be looking at your comments now. Can you please tell me what type of connection do we use between the gateway and network server? What sort of protocol do we use? Do we use LoRaWAN or? So I'm waiting for your feedback, guys, on that question. Hello, Munir from Morocco. Hi. Anyone? What sort of connection do we use between the gateway and the cloud? The network server is the cloud now, okay? So what sort of communication protocol do we see? Do we use LoRaWAN between the gateway and the network server or the cloud? Come on, guys. We mentioned this at the beginning of the presentation. Okay, I'm going to give you options. Do we use the internet, or do we use, for example, Node B IoT? Okay. I'm not getting any feedback. Can you guys hear me? Okay. Okay, I'm going to go back to the presentation. We're going to see all of this when we come to the quiz side, I guess. Okay, so from the gateway to the network server, we are going to use the internet, okay? So all the communication protocols that I talked about earlier, LoRaWAN, Ingenu, Weightless N, Node B IoT, EMTC, extended coverage GSM, all of them operate between the end devices and gateways. Why don't we just use the standard internet here? Because internet is heavy, it's a heavy stack, type of protocol stack. It has high power requirements. So we developed those low power protocols to support the communication between the IoT devices to gateways. And then from the gateways to the cloud, we just use standard internet, okay? So this is the typical protocol stack for LoRaWAN devices. So we have an application. LoRa is the MAC layer of LoRaWAN, okay? So حتى أنا الوقت قريب. So like what's the difference between LoRa and LoRaWAN? Okay, so LoRaWAN is the protocol, the communication protocol. LoRa is the physical layer of LoRaWAN. Okay, so LoRa supports the modulation. So the modulation used in LoRaWAN is Chirp Spread Spectrum. We're going to talk about it in a little bit. And then also the MAC layer of LoRaWAN. And then LoRaWAN is on top of that, basically. Okay. So LoRa uses Chirp Spread Spectrum. It's also one of the resilient okay. Just 1 second, guys. I'm talking to the admin. Okay. Okay. So LoRa uses the physical layer of LoRa uses the communication standard called Chirp Spread Spectrum. All chirps have particularly the same time duration. We don't need to worry about the communication details of that, but it's also a resilient communication protocol, okay? So it supports two type of, like it has different bandwidth capabilities and different code rates, okay? So like, for example, if the spectrum conditions are good, then we're gonna operate at a high bandwidth with a high code rate, you know? So those are the features why Chirp Spread Spectrum is actually a resilient protocol. Just gonna go quickly over that. I want to go to the use cases. Okay, so I just selected some use cases where LoRaWAN actually operates good, and we should go for LoRaWAN in such an application. And some cases where LoRaWAN is not as good, and you should look for an alternative. Okay. طيب بسم الله. I'm gonna try to go back to Arabic here. طيب اليوز كيسز اللي اخترتها عشان نتكلم عنها هتكون real time monitoring، مثلا agriculture applications، metering مثلا حق for the home use of مثلا of electricity or gas or موية مثلا. Okay. Smart city applications، city مثلا like transportation in a city, logistics, also video surveillance، وكمان healthcare. Okay. طيب قبل ما ادخل على اليوز كيسز let's see يعني دائما every year I look at the hype cycle Gartner hype cycle for the technology that I'm interested in واشوف وين الدايركشن حق التكنولوجي ماشي مثلا. اوكي ف this back in 2016 كانت ال IoT is owning the hype. اوكي يعني كان في enabled IoT platform, IoT services, IoT edge architecture. The things you see at the left of the hype cycle are stuff that we are going to see in the future. الحاجات اللي نشوفها at the through of the disillusionment حاجات اللي هي خلاص deployed وحتطلع من الماركت بعد شوية. اوكي ف if something is down here that doesn't mean that it's not good or it's not people are not interested. بالعكس لا هي معناته هي already كانت هنا و got deployed وخلاص you know الحاجات اللي ممكن we research about it و it's coming on the future usually we found it at the left of the hype cycle. الستاندرز لانه احنا الحين قاعد نتكلم عن الستاندرز حقت البروتوكولز ف they were talking about 802.11 for IoT. LoRa كمان يعني this is in 2017. okay Node B IoT, machine to machine, Sigfox. Let's see how things are today. So and this is the most recent one I was able to find in 2020. Okay, so they're using خلاص يعني IoT is deployed. okay for IoT in healthcare is still يعني a big hype. IoT security. okay IoT edge architecture and edge computing and fog computing are also a big thing but يعني they are deployed for we see them at the down of the hype. For the protocols LoRaWAN is I'm assuming that's going to be at the end of the hype because it's highly deployed. okay LoRa is widely used. Node B IoT not as much. okay but this is how we look at things. IB version 6 is also used يعني in كان زمان هنا IB version 6 now it's used in IoT and we're going to see when we talk about the internet. طيب so real-time monitoring. So when you see a green circle that means go for it. LoRaWAN is a good standard for real-time monitoring like our agriculture or like drones or so because it supports high range. So LoRaWAN can go up to 10 kilometers by the way. The data rate of the applications حقت agriculture والزراعة وكده ف usually what do they measure? They measure soil moisture stuff like that. The amount of data that are sent by those applications is not much it's good. okay so we can go for LoRaWAN when we do agriculture monitoring or real-time monitoring. Sorry about this here might not be very clear. Industrial applications of IoT are no. Don't go for LoRaWAN when you do our industrial applications, okay, or IoT basically. Why? Because those applications usually require very low latency, okay, and LoRaWAN cannot support that. okay يعني LoRaWAN with the highest في something called with the LoRaWAN called the spread spectrum factor. Even when we use the best one latency حقت LoRaWAN is usually 40 milliseconds and the IoT might require like a more tight constraint than that. So we don't go for LoRaWAN. We don't see LoRaWAN deployed in industrial applications. Okay. Okay. So the spreading factor is actually the one that controls the latency within LoRaWAN, and even if we, as I mentioned, we operate with the best one, we can't satisfy the requirements of the IoT. Okay. Another thing that actually also hinder the use of LoRaWAN in IoT is the access method used in LoRaWAN. LoRaWAN used the medium access method for LoRaWAN is a random access method, you know. So it uses Aloha, where you just send a packet, okay, into the medium, because the medium is shared by different IoT devices, right? It's not just dedicated for a single. So the medium between the different IoT devices and the gateway is is the same, right? So they operate at the same, for example, channel, etc. If two devices sent a packet at the same time and they collided, what happens is that they will just wait for some time and send again. They might collide. So this collision really hinders the reliability of the protocol, and it cannot be used for real-time applications with very tight time constraints. Metering, okay, metering could be both ways. So if a metering does not require real-time feedback، اوكي يعني بس انا الكهرباء مثلا عادي انا في النهايه I send my, for example, my usage, and then at the end of the month they will give me my bill. In this case it's okay. But if the metering is requires, like if the usage is like measured by seconds or by minutes, or and I need to meter the user right now, okay, then I might not be able to use LoRaWAN in that case. Okay. Smart cities, again, here I have formatting issues. Smart cities also okay. So and usually the timing constraints within smart cities are not that tight, but here I'm gonna remove those videos away because LoRaWAN cannot support the surveillance. Video surveillance cannot be supported by LoRaWAN because the data rate is very high. Okay, and even the lowest data rate for video surveillance is higher than the highest data rate LoRaWAN can support. So we can't use LoRaWAN for that. For transportation, it's also so and so. For example, I can use it for logistics, like مثلا FedEx, those people, to track the place of the different parcels I have. But if I need it for real time, like where the bus is and those type of things, something is very critical, and for example, I'm going to use it for like self-driving cars, those type of things, definitely no. Okay, so again, it depends on the specifics of the application. For healthcare, it can support the majority of the application, but again, if the application is critical where I need data within milliseconds, if they're using for remote surgery, remote robotic surgeries, and etc., then no. But for different remote patient monitoring applications, then it can be supported. So I think I need now, I'm not going to go into the open research challenges with LoRaWAN, but those are the main issues with it. The duty cycle of LoRaWAN limits its performance, and also the medium access method and the lots of interference we have. Okay, so do we have just talk to the admins? Okay, so the second part that I want to talk about is the connection from the gateway to the cloud. Okay, so what we have covered so far relates to the connection between the connection between the end devices, okay, and the gateway. طيب خلينا نشوف كيف ال gateway is connected to the cloud. طيب why do we use the internet? Why don't we use a specific protocol to connect the gateways to the cloud? Internet is widely available. It's used by يعني, like we can have just an Ethernet cable and then we are connected to everywhere. It's a standard use, and the protocol stack used for the internet is called TCP/IP. Okay. So what does the internet protocol do? Means that your device can be accessed by anyone, like at any time from wherever. So if you have a laptop and your device is thousands of kilometers away, just that because it's connected to the internet and have an IP address, then you can access it. It provides ubiquitous connectivity. Our IoT devices is that we don't have an IP or does not support IP، معناتها ما حنقدر نوصل to our IoT devices. Okay. And the fact that they use LoRaWAN and stuff, that means they're not accessible to us directly. We can access the gateway that controls them, and then give it some instructions, and then they can relate to the particular device, but we cannot access that specific device directly. The protocol stack for the IP internet protocol for IoT looks like this. Okay, those are our we said يعني اللي هي devices do not use IP, right? So they are outside the IP protocol stack. We see them scattered around Wi-Fi, Bluetooth, 102.15.4, LoRa, LoRaWAN, Zigbee. Okay, everyone are outside. So we communicate from the end devices to the gateway using those, and then the gateway supports both. Okay, this is very important. إنه الgateway يعني تقدر تتكلم مع الاند ديفايس with the LoRa or LoRaWAN، وتقدر كمان تتكلم مع الكلاود using الانترنت. في الجيتواي supports both communication standards. Okay, so ال TCP IP protocol stack case here, they are trying to develop, or it's already developed, a 6LoWPAN. 6LoWPAN is an IP version 6 based protocol stack for the IoT. Okay, so and that's how important the IoT is becoming, that they're developing a whole protocol stack for to support it. And we have different type of IBs, version 4 and version 6, and they can the transport layer can either be over TCP or UDP. Okay, TCP is more power hungry, data hungry, so but it's the internet is over TCP. Okay, and those are the messaging protocols that we use between the IoT devices and MQTT. This is the message structure of the IoT. So if a message is sent by an IoT device, usually it's in one of those formats. Okay. I think this is like a bit of a background. We have different types of IPs. Basically two, version 4 and version 6. Why did we have to go from version 4 to version 6? Because really the IP addresses have been like exhausted. Okay, we're having more devices, and IP version 4 cannot support more devices basically over the internet. So we need لازم كان ندخل الاي بي version 6 يعني يكون عندنا more options for IPs basically. Okay. So the addresses are almost exhausted. IP version 6, it has 16 bytes for the address. Can you believe it? 16 bytes for the address. كم البايت عبارة عن 8 bits, right? So okay, so Muhammad has a question. 3G and 4G are considered high rate and low power? No, those are high power. Those are high rate, high power. Okay, so those are big no for IoT, right? And so they developed alternatives. هنتكلم بالعربي since اسمه محمد عمر. طيب هم نفس الناس اللي developed ال 3G وال 4G اللي هم 3GPP عملوا standards low power low data rate to support ال IoT. اوكي، فحتى اذا انت حتستعمل licensed IoT protocols ما حتستعمل 3G و 4G، حتستعمل اللي هم ال alternatives اللي هم we mentioned them here, those three هنا EMTC, Node B IoT, and extended coverage GSM for IoT. Okay, so going back, so this is the structure of the IP version 4. I don't think we need to go into the details of this. The most important thing is just like the takeaway here is that the IP version 6 offers lots of addresses, IP addresses to be used because the IP version 4 addresses has pretty much been exhausted. Okay, this is the naming of a device in an IP version 4 address. We either give it the decider notation. Okay, basically we are saying that when you say 16, that means The subnet mask is taking the first two like segments, okay, and then the others are used for the device addressing. I'm not sure if we need to go here. Okay, so what are the benefits of using the IP protocol for IoT? Like having our IoT being directly accessible, okay, and عندي مثلا a sensor that's in my fridge and I can directly access it and do stuff with it. So the IoT devices are directly accessible, so you can access it from anywhere and just do whatever configuration you want, okay. So and the interaction would be very easy. And also the programming, if it supports IP, because there are lots of APIs that supports IP networking. The challenge with this is that the bucket size is huge, okay. So if you're going to do with IP, especially for version 6, and now everyone is moving to version 6, the MTU is the minimum transmission unit, is 127 bytes for 1,280 bytes for IP version 6. Can you imagine that a small, poor little IoT device can support such a high data rate? The address sizes are also huge. Even the fact that the address size for IP version 6 is huge for the يعني عشان this device to be able to تحفظ اسمها بالنسبة لها مشكلة. نحن and we're talking bytes are like scarce when we talk about this little computational IoT device. So this is also hinders the deployment of IP directly into the IoT device, okay. IP assumes that device on a subnet can be reached with a link layer message, does not hold in multi-hop wireless networks. Okay, multi-hop, that means to reach the gateway, you don't يعني ما في direct line of sight communication between the end device and the gateway, okay. If we are dealing with multi-hop networks where a device hops to another device and then, for example, for another third device, and then the fourth one is the gateway, then this would make it hard for us to reach the device directly, okay. So there are lots of challenges with deploying IP into the end devices of IoT, but it has its benefits. Currently, this is not widely supported. Usually the devices deals with the gateway within those protocols that support low power data rate that we talked about, like LoRaWAN, and then the gateway talks to the cloud versus through the internet. So so let me go back. I think this is it for today. We're not going to hold the quiz because we have the quiz is going to be delayed till the last session. Just saying that the quiz is going to involve all the sessions we have covered so far. I know that you don't have the slides, okay, but just try to revise or watch the videos if they are available. Okay, so the next session we are going to cover a project that I'm working on that I use IoT and machine learning, and we're gonna do a small quiz. And yeah, if you have final questions, if you're working on any projects that you want us to look at, that could be done as well. Let me see if there are any. So the quiz is not today, no. Let me see if there are any questions. Thank you, Salman. So that's just a reminder. You see the quiz is there. So yeah. So if we don't have further questions, we're gonna be done for today. But just I hope that you come next time ready for the last session and the quiz. It's gonna have some Python questions and general IoT questions. Okay. So I'll see you next time, guys. Bye.